All righty, so we're going to talk about a few basics of this, something that you just kind of need to know, and then we're going to dive into some examples. And I may go just a little out of order from the book, but I'll tell you when I'm doing that so that you kind of have a good idea of where to find this stuff. So the first thing we're going to talk about is, what are we doing? We are solving what we call systems of equations by graphing. So let me write that at the top. We're doing systems of equations. And what we're doing is we're solving those systems by graphing. So a system of equations is just basically you have more than one equation of a line in this case, okay? And to solve that, you're finding where do those two lines intersect. So solving a system of equations means we're finding where they intersect when you graph them. So I'm going to give you 3 examples here of things you might encounter. So the first example is, what if you had a line like this, okay? And then you had another line like this. This is going to be our most common example here. And the solution of the equations is right here where they meet. We would say that this equation has one solution, okay? Because there is exactly one place that it meets, okay? Now, another example that we could potentially have is, what if we have a system of equations and we go to graph the first one and it's right here, okay? We've maybe used slope-intercept form and we graphed it and this is what we got. And then let's say maybe we had another equation and it was given to us in point slope form, which you learned yesterday or the day before, and you went to graph it and it ends up in the exact same spot, okay? Same line. I'm going to write that, same line. Well, what happens is that there are actually infinitely many solutions. I just wanted to write that exactly the way, infinitely many solutions, because any XY pair that's a solution for the first one is also an XY that's in the second one as well, okay? And then let's get to the third one that you could encounter. And so here's my graph. And so what if you had a line like this, okay? And then your other line was right down here, okay? And they happen to be parallel lines. So parallel lines, okay, what's special about them, oops, I can't spell parallel lines. I was going to say signs. Parallel lines, they have the same slope. You'll learn that when you get to geometry if you haven't yet. And we actually, since those never cross each other, we say they have no solution. Okay, so you need to take these notes. You need to know what it looks like for each of these different scenarios and how many solutions they have. The other thing that I'm going to have you write down here at the bottom of your page is what we're going to call a classification. I'm going to move this out of the way for now. So the classification of this one, classification, okay, because you're going to have to classify these later. We're going to say that this is consistent. This is a vocabulary word. And we're also going to say it is independent. Independent. I can't spell. You can spell independent. Okay, so it's consistent because there is at least one solution. Okay, I'm going to write that for you. At least one solution. Okay, at least one solution. And it's independent because it's exactly one solution. So let's look at this second one with these kind of definitions in mind. Okay, we have infinitely many solutions. That means it definitely has at least one. So it is also consistent. Okay, Does it have exactly one solution? No, it does not. So we say instead of independent, we say dependent. Okay. And then our last one, does it have at least one solution? No, it does not. So let me move this little guy out of the way. So we're going to say this is oh, now I can't write, can I? Okay, we're going to say this is inconsistent, and then I'll move that out of the way. And because it is inconsistent, we don't need to do this second one. Okay, so write these as notes. Make yourself a little table that has the picture, how many solutions has, and maybe something special like this same line or parallel line and slopes, and then do the classification. I did those in slightly different colors. You might want to think about that or highlighting to make note of what is special here. Okay, so with that, I'm going to erase, but you're going to pause and write this down. And we're going to do first a little bit of practice with graphing these. And then we'll also do these classifications. So hang on, gotta erase so much stuff. All right, so let's get my bright green pen again. That one's the best one. Unless you disagree, you can tell me in the comments. Oh, wait, no, you can't. I disabled the comments, but you can tell me somewhere else. Okay, so let's try this one. We're going to start with, yeah, this is what I want to start with. I want to start with example 2 in your book, and then we'll come back to example 1. So 5x minus y equals 3. And negative x plus y equals 5. So this is what we're going to graph. So let's first figure out, how do we want to graph these? Well, my preference of graphing is always going to be to put it into slope-intercept form. That's the easiest way. So let's do that with this one. So we have 5x minus y equals 3. I'm going to subtract 5x from both sides. That's why this last lesson was so important, was making sure you know how to do this. And now I'm going to divide by -1 on both sides. So I have y equals -5 divided by -1 is positive 5x. Positive 3 divided by -1 is negative. So we're changing the sign there. Okay, this one right here, I'm going to erase this first one since we already wrote it down. I'm going to move the other one up a little bit. That way we have plenty of room. So -x plus y equals 5. Let me erase this. And let's come over here and do this math. So I'm going to add x to both sides. So y equals x plus 5. So now I've got this that I can graph easily. I'm going to go ahead and use my actual graph paper. But obviously, if you're doing this on a sketch, you can do that. I want to put mine on graph paper because I think it'll be neater and easier for you to read. So here we go. I'm going to go ahead and graph this one first. Doesn't matter which one you do first, but my plus 5 is my y-intercept. So that's going to be right here. I'm going to make a little, oh, I'm not on pen mode. Grr. Okay, so I'm going to just make an x because I'm having trouble with my points. Okay, so that's one of my points. And my slope is positive 1 over 1. So I'm going to rise 1. Rise 1. Okay, now I'm going to go the other way. So I can just keep on doing this until I'm happy with how many points I have and start drawing my line. I think I want my line to be red so that it's easier to see, but maybe it won't be easy to see. I'm sorry, guys, my lines are really bad, but I am trying. Okay, so there we go. We have our first line. Now let's grab our second line. So this one is y equals 5x minus 3. So we're going to come down here to 1, 2, 3. That's at -3. We're going to go up 5, 1, 2, 3, 4, 5 over 1. Up 5, 1, 2, 3, 4, 5 over 1. So it's the same point, which is going to give us a hint for our next part, which, where does this line cross each other, is right here. This line's going to kind of be gross, but I tried my best to stay on the lines. Okay, so this is where these lines cross. And so we need to figure out what point that is. That's at point 2, comma, 1, 2, 3, 4, 5, 6, 7. So 2, comma, 7. This is what we call is the solution to the system of equations. The answer is always going to be an XY point. Now, go back to the beginning of the video, go back, pop up to your notes. Remember, how would we classify this? We say this has one solution. Okay, the solution is 2, comma, 7. It is consistent. I don't know how to spell consistent. Consistent. Yeah, now it looks right. Because it has at least one solution, and it is independent because it has exactly one solution. Independent. There we go. Okay, so that's how you're doing this kind of question, is really just put it into slope-intercept form, neatly graph it. The neater you graph it, the easier it'll be to find what point that is, and then figure out what your solution is. So where do they cross? So that's what you're doing here. I've decided not to actually go back to example 1 because example 1 is to do the, classification. And if you can graph it and do classification, then you can definitely classify it. I recommend just going ahead and graphing it every time. I think that's the easiest choice. So with that, I'm going to go ahead and stop this video and let you do some practice on your own. Then you can come back when